we'll light a scene from the Swords and Shovels game developed by Pluralsight from start to finish. Before we get into the lighting itself, we'll discuss important considerations when developing lighting for a game, and then we'll look at the scene and plan out our lights. Next, we'll touch on Unity's new post-processing stack, and we'll add some interesting render effects to our scene. Finally, we'll wrap up everything with a final pass of our lights. Let's take a moment to discuss some considerations to make before you begin to light your scene. These are all decisions that should be made about your game during pre-production, so by the time you're in the engine, it's just a matter of setting values and following established methodologies. The subjects we're going to be discussing here are rendering paths, color spaces, and finally mood. Rendering paths are a slightly more advanced topic, but it's important to mention them in this Foundations course because they directly affect the qualities of light and shadows in your game. There are two main rendering paths that we'll be discussing here, deferred and forward. Let's start with deferred, which will be the rendering path we'll be using in our game. With the deferred rendering path, there are no limits on the number of lights that can affect the objects in your game. Lights are evaluated per pixel, meaning the transition of light across a game object will appear smooth and naturalistic. In addition to better overall appearance, there are several advantages to working with the deferred rendering path. The processor expense is directly related to the number of lights in the scene versus the complexity of the game objects in it. This means that if a scene has only a few lights, it will perform very efficiently, and conversely, if a processor-heavy scene needs to be optimized, removing a few lights and editing the remaining ones to make up the difference can help significantly. There are also a few disadvantages. The deferred rendering path does not support anti-aliasing, meaning that objects in the scene can have a jagged-looking appearance. Fortunately, we could offset this issue by making use of the post-processing stack. The deferred rendering path also can't handle semi-transparent objects. Unity automatically converts any objects of this type to use the forward rendering path so they display properly in game. However, they will not be able to receive shadows, which can potentially be problematic depending on the style and contents of your scene. The forward rendering path renders objects in the scene in passes depending on how many lights are affecting them, and it limits objects to receiving information from a maximum of 4 lights. It also changes the way that lights are managed. Only a limited number of lights are able to be rendered per pixel, and the remaining are rendered per vertex. The difference in the size of the lighting calculation can be significant depending on the complexity of your object. That means that lower poly objects are going to look more blocky. Forward rendering also does not support cookies or normal maps, and limits only one light to have shadows by default. All that being said, when used correctly, the forward rendering path is extremely fast and efficient, having practically zero processor cost. This means that it's ideal for mobile, especially if you're trying to target the maximum number of mobile devices, including lower-end models. The next topic we want to touch on briefly is choosing a color space. It's not very often that you'll be changing this, but it's important to be aware of it as you move forward with lighting. Color space determines how color mixing will work in the lighting calculations in your scene. The two color spaces are linear and gamma. The linear color space is the default space in Unity. It looks more realistic and colors will brighten linearly as light intensity increases. This means that the colors won't become washed out as quickly. The second color space is gamma. With this color space, colors quickly turn white as brightness increases. The need to work with gamma color space is relatively limited, but it is sometimes necessary if you're targeting a broad range of mobile devices, again including lower-end mobiles. In the past, it was also a requirement on some consoles, but that isn't the case any longer. The final consideration that you should make before lighting your scene is what kind of mood you're trying to establish. Both color and quality of light will contribute to the mood of a scene in a variety of ways. Let's start by talking about the importance of color. Color tends to have a great deal of cultural significance, whether or not people are expressly aware of it. It's important to be aware of the fact that games themselves have their own developed culture, and color expectations are very much an element of that. Let's take a look at some examples of the use of color in games. Thinking from the perspective of a gamer, what do you think when you see the color red? It's very likely a negative connotation. Stop, danger, maybe health loss. What about green? Generally, this color means safety or health items. Finally, purple. Very often, this color represents poison. This isn't to say that there's a universal color code for games. There are plenty of examples of red health items or poisonous green items. Color is also very situational. Red tones in a sunset scene may be perceived as warm and comforting, but those exact same color values will exude danger when they're produced from a room on fire. The most important thing to do when determining your own color scheme is to remain consistent with it throughout the game. Avoid alternating between positive and negative connotations of colors. Even if your players don't realize it, they'll be learning the rules about your world based on your color choices, and you want to communicate clearly. Last but not least, let's take a moment to discuss the importance of the amount of light in the scene. Humans naturally seek out light. If you put a person in a large dark room with a single small light source in the middle, that's exactly where they're going to move to. Limiting light can give the player a sense of unease, which is formed from the animalistic fear of predators, the idea that there's something out there around you that you can't see. This is a powerful tool for communicating to your player what they should be feeling in a scene. Is this a dangerous place? Should they be feeling safe? Or on edge? Conversely, extremely brightly lit scenes don't necessarily have positive connotations either. Bright, flat lighting without shadows can give the feeling of a cold or unemotional environment. Think of cubicle-filled offices, or even a doctor's office. This sort of lighting can also feel somewhat alien, which is why it is often utilized in futuristic scenes. There's a lot to consider when planning out how to light a scene, but don't let that make you feel overwhelmed. Just remember to start with the question, how do I want my player to feel? And build from there. Remember, lights are easy to change in Unity. Don't be afraid to experiment as you go.